Question 11 says to solve the following equations for all values of theta, you will use the 2 pi k notation. So you're trying to figure out what values of theta is going to make this equation true. So you're going to solve the equation. Your tangent is already by itself. There's nothing that you need to add or subtract or multiply or divide, but it is squared. So to solve that, to get tangent by itself, you're going to take the square root of both sides. And anytime you do that, you need to remember that you're going to get a positive and negative solution. So on the left side, the square root of tangent squared is going to just be tangent theta. And on the right-hand side, you're going to take the square root of 1/3. You can take the square root of 1 is 1, and the square root of 3, we're going to leave it as the square root of 3. You could rationalize that. However, it might be more useful to you to leave it in that form as you think about what values or what angles would give you a tangent of 1/√3. If you did rationalize it, it would end up being √3/3. So some of you might just have that already kind of memorized. If you're not sure, go to unit circle and think about, okay, tangent is y/x. So if I am getting a 1/√3, I need the bottom part of my fraction, my denominator, to have a √3 in it. So on my unit circle, what has a √3 in it? What has a √3 is this √3/2. So I could put in √3/2 here, and my y value would be 1/2. If you then simplify that, you would get 1/2 multiplied by 2/√3, because you would be taking the multiplying by the reciprocal. Those two 2's would cancel, and it would end up giving you 1/√3, which is what you want. So the way that you would get tangent is if your x value was √3/2 and your y value was 1/2, and so therefore your reference angle would be pi/6. So you need to think, okay, where else on my unit circle would I also get the same tangent value? So if my x and y were positive, then I would get positive 1/√3. If my x and y were negative, I could also have a negative √3/2 and a negative 1/2, and that would occur in the third quadrant. If I had a positive √3/2 and negative 1/2. If I simplified that, that would give me negative 1/√3. And similarly in this quadrant, I'm kind of running out of space here, but that would also give me a tangent value of negative 1/√3. So this equation here has 4 possible solutions: pi/6, 5 pi/6, 7 pi/6, and 11 pi/6. Now you could list those out, but also remember, it's not just those 4 solutions. They're going to repeat as you go around your unit circle. So you want to write those solutions in the most efficient way that you possibly can. So if you think about it, if you look at pi/6, to get from pi/6 to 7 pi/6, we're going to just add pi. So you could write that solution as pi/6 plus pi k. It doesn't only repeat when it goes all the way around, it's going to repeat once you add pi to it. You can kind of see that these form a straight line through your unit circle line segment. And then you can do the same thing with this one here. This is 5 pi/6. And if we add pi to 5 pi/6, that's going to take us to 11 pi/6. So we could write the other part of the solution as 5 pi/6 plus pi k. And that will give you all the possible solutions that you could have, where if you put those values in for theta, it would equal, the left side would equal the right side would equal 1/3. Just a reminder, when you get something like this, it's kind of like making an X here. You cannot just write it as one of these angles plus something k, because the angle between pi/6 and 5 pi/6 is not the same as the angle between pi over 6 and 7 pi over 6. So you do need to split it up into those two statements, but you don't want to write 4 different statements because that's really redundant. You want to try and do it in the most efficient way that you can.